Hi everyone, today we are going to be looking at a new type of source. So far we have a current source, voltage source, and then resistors as components. We're adding a new kind of component, and it is a source, and they are dependent sources. So dependent sources are simply sources that change based on another source, okay? And that's really all there is to it. We have four different types of sources, dependent sources. We have a current dependent voltage source, and it's a voltage source because we have the plus minus um, inside the little square diamond thing. And here's the counterpart of it, and this is a voltage dependent voltage source. So it depends on VD, but it's treated as a voltage source. And this one is dependent on a current IA, but it is treated as a voltage source. And likewise, we have a voltage dependent current source, and this is just a simple, current source, but it's dependent on another voltage within the circuit. And I think you get the gist of it. This one's the same thing. It's a current source that's dependent on another current somewhere in the circuit. So that's basically it. We're going to do a few relatively simple problems to work out so that we can really understand how these are found in circuits. So here's the first example, and thankfully we've already labeled all of the nodes. There is one node that I would like to expand a little more, and that's V2. So this is a super node, and unfortunately I did not have a video kind of like the super loops, or during the loop analysis I um, made it a priority to make a problem using a super loop, but I'd forgotten about super nodes. So I don't remember which video it was on, but we did an example with a super node. And so here's another one of those. So basically, this battery forces 3 times V1, and V1 is related to this V1 right here. It's dependent on the voltage at this node, okay? And we'll just go ahead and call that node 1, and this one node 3. And this is big N2 because it's a supernode. And so the V2 is forced with this 3V1. So we have another node right here that can be related as V2 plus 3V1. And we are going to treat all of these guys together. Okay? So let's go ahead and write our nodal equations, starting with N1. And in N1, we have V1 minus V2 over 6 plus V1 minus 0 to ground over 8 minus 3, because we have 3 currents going into the node from the top, equals 0. I'm going to go ahead and simplify this. I'm going to multiply by 24. And we are left with 7V1 minus 4V2 equals 72. Let's go ahead and solve for this supernode. So we're going to go ahead and look at this portion first. So we have V2 minus 2 to that battery right here over 10 plus V2 minus V1 over 6. And now we are going to take into account this portion of the supernode. So we're going to have plus V2 plus 3V1 minus V3 over 4 equals 0. And notice that with this voltage dependent voltage source, we just introduced v1 in this branch again because it is related to there. And we could very well say that this v1 is related to v3, and the problem would be quite different. Okay, so I'm going to go ahead and multiply by 60, and let's simplify. And we are left with 35v1 plus 31v2 minus 15v3 equals 12. And last but not least, we are going to solve for the nodal equations for node 3. And this should be pretty simple and straightforward. We're going to start with the supernode relation, v3 minus v2 plus 3v1 plus, divided by 4 ohms plus v3 minus 0 over 6, because we're going to round, plus 3 equals 0. Once again, we're going to solve it out. I'm going to multiply by 24. And we are left with negative 18 minus 6v2 plus 10v3 equals negative 72. I'm going to go ahead and put these equations side by side so that we can go ahead and just plug it straight into our calculator. I'm not going to put it in a matrix this time so as to save some time. And when we calculate this out, we are going to get V1 is equal to 6.457 volts. V2 is equal to negative 6.709 volts, and V3 is equal to 0.387 volts. And the problem asked us to solve for each one of the V1s, V2s, and V3s, and we did. So that's how you solve a voltage-dependent voltage source, a circuit with a voltage-dependent voltage source. Well, let's go ahead and do one more. Okay, here we have a current-dependent current source, and we're trying to find I right here. The best way that I can think of doing this is, because we're trying to find a current, I would use loop analysis. So, but I noticed something. This right here is a current source. So because it's a current source, we can either do a brute force approach, or we can do a super loop approach. And I think I'm going to opt for the super loop approach because I think I can see a good super loop. So first, I'm going to draw I1 in the direction of I, so that I1 can just equal I, okay? And I see that we can force 8I to just go into this one loop right here. So we'll call it 8I1 because I equals I1. And we are going to draw a super loop around here, like so. We're going to call that I2. And this will be loop 1, and this will be big loop 2. Okay? So let's go ahead and write the equation down, the KVL equation, or loop analysis equation for I1. I'm going to go ahead and start from right here. We're going to have 4I1, and we have I2 opposing us in this branch. And then we're going to go through the 1 ohm resistor, and we're only going to have I1, and then minus 4, because we're going into the negative way of the current of the battery. And we have one last resistor, the 6 ohm resistor. We have I1 going in that direction, and we have I2 opposing us, and we also have 8I1 opposing us, and all that equals 0. I'm going to go ahead and simplify this. And we are left with negative 37I1 minus 10I2 equals 4. Now we're going to do the big loop, the super loop L2. I'm going to go ahead and start from right here. We're going to have -4 plus, and we have 4 ohms, and we have I2, and I1 is opposing us because it's going in the opposite direction. We are going to add 6, and once again, I2 minus I1 minus 8I1 because they're opposing us. And then we're going to have plus 2 I2 plus 8I1 because 8I1 is helping us. Oh, I made a mistake. 8I1 is actually helping us here because I2 and I1 are going in the same direction. And plus 2 plus, we have this 1 ohm resistor down here, so we have 1 and I2 plus 8I1 because it's helping us, plus 10. And in this case, there's only I2 in the 10 ohm resistor by our convention. So we get 0 right there. I'm going to go ahead and simplify this out. And the simplified equation is 62I1 plus 23I2 equals 2. If I did my math correctly, please check in the comments. And I'm just going to go ahead and write down the answer, and that is I1 is equal to -0.4848. I2 is equal to 1.393 amps. And as we said before, we're looking for just just I, and we said that I1 would be equal to I, and so the answer is -0.4848 amps by convention of whoever set up this problem. All right, and that's just a brief introduction to current dependent, source dependent sources, essentially. And we will be seeing these sprinkled around a lot more. It's not too difficult of a topic, and yeah.